Hello, this is Sareen from Exam Help Lab. Today we will be solving Chemistry Paper 2 AS Level Structured Questions 9701 Variant 3 May-June 2019. Starting with question number 1, Part A. A sample contains 3 different types of atoms, uranium, potassium, and calcium. Part 1. State fully in terms of the numbers of subatomic particles what these 3 atoms have in common. So they all have in common same mass number or atomic mass, which means they have same number of total number of protons and neutrons. So you need not write both the things, you can write either. Part 2. State fully in terms of the numbers of all subatomic particles how these 3 atoms differ from each other. So they all have different number of protons, electrons, and neutrons. Part B. A sample of sulfur contains only 2 isotopes, sulfur 32, sulfur 34. The relative atomic mass of the sample is 32.09. Calculate the percentage abundance of the isotopes present in this sample. So the formula is relative atomic mass is equal to first isotopic mass multiplied by its abundance plus second isotopic mass multiplied by its own abundance. This whole gets divided by 100. So RAM has already been given to us, which is 32.09. So I'll write that over here, is equals to first isotopic mass is 32 multiplied by its abundance, which is unknown to us. So let's suppose S32 has an abundance of X%. Multiply it with X plus second isotopic mass is 34 multiplied by its abundance, which would be 100 minus X, since X was the percentage abundance of S32. This will be 100 minus X. This whole gets divided by 100. My X has a value of 95.5%. Since in this question X is associated with S32 and 100 minus X was associated with S34, so percentage abundance for S32 is 95.5% and S34 is 4.5. Part C. The electronic configuration of a sulfur atom is 1s2, 2s2, 2p6, 3s2, 3p4. Part 1. Identify which orbital in a sulfur atom has the lowest energy. It's 1s. So here it's starting from least to greatest, where 3p4 being the highest energy level and 1s2 is the lowest energy level. Part 2. Sketch the shape of a p orbital. So p orbital has the shape of a dumbbell. Part 3. During the process of ionization, a sulfur atom loses an electron. Identify the orbital from which the electron is removed. Explain your answer. So sulfur, first of all, has its electron orbital energy level as follows: 1s2, 2s2, 2p6, 3s2, and 3p4. It will be losing its first electron from 3p orbital. So first electron will be lost by 3p orbital because it is the highest energy level. Part D. Complete the diagram to show the arrangement of electrons within the third shell of a phosphorus atom. So first I'll fill the 3s orbital, denoting it like this, and then I'll be filling each box of 3p with one electron first, and then giving a pair to each box depending upon the valency of phosphorus. So one electron to each orbital first. Now I don't have any other electron to fill these three boxes with, so they'll remain unpaired. Part 2. Explain why the first ionization energy of sulfur is less than that of phosphorus. So sulfur has got a pair of electron in 3p orbital, and paired electrons experience repulsion due to the fact that they're like charges, so not much of external energy is required. Question number 2. Iodine is an element in group 17 of the periodic table. Part A1. At room temperature, iodine solid has a lattice structure. Describe the arrangement of the iodine molecules within the solid. They are regularly arranged. Part 2. List all of the forces of attraction present in solid iodine and identify which of these are overcome when solid iodine is heated to produce iodine vapor. So force of attraction, first force of attraction is covalent bonding, and second force of attraction between the diatomic molecule, which is also the weakest bonding, and that is induced dipoles. Force of attraction which will be overcome, that would be induced dipoles, since induced dipoles are the weakest bonding among all the other. Iodine reacts with aluminium to form a white solid, Al2I6. Part B. The diagram shows the arrangement of the outer electrons within a molecule of Al2I6. Part 1. How many coordinative covalent bonds are made when a molecule of Al2I6 is formed from its atom? So here, both these iodine atoms, this one and this one, they're sharing more than one electron pair with these two aluminium atoms, which is not the case with other iodine atoms like this one, this one, this one, and this one. So I can say that there are two dative bondings due to the fact that these two iodine are sharing more than one electron pair with aluminium atoms. So there are two dative bonds. Part 2. Describe how coordinate bonds form within this molecule. So iodine atoms donate pair of electrons to aluminium to iodine bonding. Part C. In a reaction between hydrogen iodide and concentrated sulfuric acid, the products are hydrogen sulfide, sulfur, iodine, and water. Part 1. Write an equation for this reaction. Okay. So hydrogen iodide reacting with H2SO4, and this gives hydrogen sulfide plus sulfur solid plus iodine gas and water. I need to balance this equation. 2, 14, 7, and 8. Part 2, explain with reference to oxidation numbers why this reaction is a redox reaction. Iodine is getting oxidized from -1 to 0, because increase in oxidation number means something, that substance is getting oxidized, whereas sulfur is getting reduced from +6 to 0. There is loss in oxidation number, which means it's reduction. Question number 3, part A. Magnesium reacts with oxygen to form magnesium oxide. State 2 observations that would be made when magnesium is heated strongly and placed in a gas jar of pure oxygen. So first I'll write the equation for this reaction to make it easier for me to deduce the observations. So magnesium reacting with oxygen magnesium oxide. Okay, so there'll be a bright white flame, and the next one would be white solid forming, since period 3 solids are usually white. Part B, acid indigestion is caused by an excess of hydrochloric acid in the stomach. Magnesium oxide is commonly found in indigestion tablets. Part 1, given the equation to show how magnesium oxide relieves acid indigestion. Okay, so this is magnesium oxide. It will be dealing with excess amount of HCl, and since metal oxides, they act as base reacting with an acid gives salt and water. So magnesium chloride will be forming plus water. I'll balance it too. Part 2, name the type of reaction that occurs in part B1. So this is acid plus base, which is neutralization. Part C, magnesium oxide is described as a ceramic material. It has a high melting point. State and explain why ceramic materials such as magnesium oxide have high melting points. So magnesium oxide has ionic bonding with a giant lattice structure, which requires high energy to break the bonds. Part D, magnesium oxide can be made from magnesium carbonate in a one-step reaction using heat. Part 1, write an equation for this reaction. So this could be magnesium carbonate. It is heated, and then it gives off magnesium oxide plus carbon dioxide. Name the type of reaction occurring during this process. So this is thermal decomposition. Question number 4, release of sulfur dioxide into the atmosphere causes acid rain. Part A, explain why high levels of sulfur dioxide may be found in the atmosphere near power stations that burn fossil fuels. Okay, so those power stations which have got fossil fuels to burn, fossil fuels contain sulfur. So when they're burnt, sulfur will be released in the environment, and which gets converted to sulfur dioxide when undergoes combustion. Part B, the sulfur dioxide released can be converted in the atmosphere into sulfuric acid by reaction with nitrogen dioxide gas and water. During 1 year, 1590 tons of sulfur dioxide was released into the atmosphere by a fossil fuel burning power station. Part 1, use the equations to calculate how many tons of sulfuric acid were formed in the atmosphere. Assume that all of the sulfur dioxide released was converted into sulfuric acid. So the first step is to convert 1590 tons to grams. Since 1 ton is equals to 10 to the power 6 grams, so 1590 tons will be 1590 tons is equal to 1.59 into 10 to the power 9 grams. Now calculate number of moles of SO2 by dividing 1.59 into 10 to the power of 9 grams with RFM of SO2. So moles of SO2 is equals to 2.48 into 10 to the power 7. In this question, ratio of sulfur dioxide to sulfur trioxide is 1:1. So number of moles of sulfur dioxide is equal to number of moles of sulfur trioxide. Now that number of moles of sulfur trioxide is equal to number of moles of sulfuric acid, since mole ratio of that same sulfur trioxide and H2SO4 is 1:1. Now that you have the number of moles, which is 2.48 into 10 to the power 7, and RFM of H2SO4 which is 98.065. Multiplying moles with RFM will give you mass of H2SO4 in grams, which can be converted to tons by dividing it by 10 to the power 6, and you'll get a mass of 2,433 tons. Part 2, describe how nitrogen dioxide is also produced by these power stations. So nitrogen forms the largest percentage in the air composition. However, due to its triple bonding, it's difficult to break them. A lot of energy is produced, which is used to break those end-to-end triple bond. And this nitrogen as well as oxygen comes from air. End-to-end triple bond is very strong. So energy a lot of energy which is produced is used to break that strong bond. And this nitrogen plus oxygen come from air. Although this question has only 2 marks, you can't just write that nitrogen and oxygen from air react, because it's not this normal for nitrogen gas to react. So you need to explain where is this energy coming from and how it is being used in this process. Part 3, state one natural cause of nitrogen dioxide being formed in the atmosphere. That's lightning. Part 4, explain why nitrogen dioxide can be described as a catalyst in the oxidation of atmospheric sulfur dioxide. So what catalyst is? Catalyst is a substance which speeds up the reaction but remains chemically unchanged. And so does nitrogen dioxide in this reaction. So I'll write nitrogen dioxide lowers the activation energy, and nitrogen monoxide, how do we recover nitrogen dioxide? How do we recover our nitrogen dioxide? Nitrogen monoxide will react with oxygen to form nitrogen dioxide. Question number 5. Halogenoalkanes react with a number of different reagents in nucleophilic substitution reactions. Part A. A sample of potassium cyanide dissolved in ethanol is added to a sample of 1-bromobutane and heated under reflux. A nucleophilic substitution reaction occurs and compound A is formed by one named compound A. So ethanolic potassium cyanide is reacting with a halogenoalkane. It will be forming a nitrile plus bromide ion. So my A is pentane nitrile. I'll also be showing you how basically pentane nitrile is forming arrow, and then this is part of the structure, and then there is cyanide ion extra, which happens to be there as a product. So now that in my answer, many might confuse this with butane nitrile, but you must remember that naming has a lot to do with number of carbon atoms. So the answer has now 5 carbons, so it's pentane nitrile, regardless of where it is coming, where cyanide ion is coming from, or whether this 5th carbon was there at the first place. Part 2, what is meant by the term nucleophile? It is a species which donates pair of electrons. Part 3, identify the nucleophile in this reaction. It's cyanide ion. Part 4, explain why this reaction is described as a substitution reaction, because bromide ion from bromobutane is getting replaced by cyanide ion. Part B, state the reagent and conditions needed for bromobutane to react to form CH3CH2 thrice NH2. So reagents are ethanolic NH3 ammonia, and the conditions are you heat it under pressure. Part C, equal amount of 3 different halogenoalkanes are added to 3 separate test tubes, and equal amount of aqueous silver nitrate and ethanol is added to each test tube. The time taken for a precipitate to form is recorded for each halogenoalkane. Part 1, describe and explain the trend in reactivity of the different halogenoalkanes shown in this experiment. So I would say that reactivity is increasing from chloride to bromide to iodide, which can be seen here in the table that it is taking least time for the iodide thing to form precipitate as compared to rest of the halogenoalkane, and that's due to this is due to increasing bond length, you could say, from chloride to bromide to iodide. So less energy is required to break the bond from, again, chloride to bromide to iodide. Part 2, all 3 halogenoalkanes tend to react with via the SN1 mechanism. Explain why the SN1 mechanism is favored. So SN1 reactions have a stepwise mechanism, while SN2 reactions are a single-step process. So the 3 halogenoalkanes in this question are tertiary halogenoalkanes, which means that their stability is the highest among all the other structures. So all these have their intermediate products very stable due to positive inductive effect of the methyl groups. So I'll write they are tertiary structures, and this can be the only possible reasoning for this kind of question. Their intermediate products Intermediate products are those products which are formed at the second step of the process. Means they are not the final products, but they are halfway to the final product. So intermediate products are very stable, due to positive inductive effect of all the three methyl groups. Part 3. Identify a halogenoalkane which tends to react with an aqueous solution of silver nitrate and ethanol via the SN2 mechanism. So SN2 mechanism, we can mention any which has primary carbocation. So I'll just write maybe chlorobutane, 1-chlorobutane. Question number 6, part A. 3 alkenes X, Y, and Z have the same molecular formula. Part 1. Describe what is seen when aqueous bromine is added to X. So these are alkenes, means there is double bond, and whenever there is a double bond and we add bromine to it, the solution will turn colorless from brown. X, Y, and Z are reacted separately with hot concentrated acidified manganate ions until no further reaction occurs. The carbon-containing products are shown in the table. Part 2. Draw the structures of X, Y, and Z. So the rule is, when there is carbon-to-carbon double bond and this carbon atom is bonded to two hydrogen atoms, when this kind of structure reacts with hot KMnO4, this will only be producing carbon dioxide. Okay, when there is carbon-to-carbon double bond and then there is one hydrogen attached to it, and the second thing which is attached to it is an alkyl group, this kind of structure, when reacts with hot KMnO4, this gives you an acid, a carboxylic acid. And that carboxylic acid will have a structure like this. This will be bonded to the same alkyl group as present in the reactant. If a carbon-to-carbon double bond is bonded to two different alkyl groups, or even though they're the same alkyl groups but is bonded to alkyl groups but not hydrogen, when this kind of structure reacts with hot KMnO4, this gives off a keton. The keton has a structure and it would somewhat look like this. There will be alkyl groups on both the sides of carbon. So it can be seen that when X reacts with hot KMnO4, it is forming carbon dioxide, which means on one hand of carbon-to-carbon double bond are two hydrogen atoms. So I'll draw that first. On one hand, there are two hydrogen atoms. And the second product is over here is keton, which means on the other hand of carbon-to-carbon double bond, there are two alkyl groups, and those alkyl groups are methyl groups, because I can see there are twice methyl groups over here in the keton. So over here I'll be having CH3. Okay, now when Y reacts with hot KMnO4, it forms carbon dioxide, which means on one hand of carbon-to-carbon double bond are two hydrogen atoms, C to C double bond. Suppose on the left I have two hydrogens bonded to this carbon. And second product is a carboxylic acid over here, CH3CH2COOH, which is propanoic acid, which means on the other hand of carbon-to-carbon double bond is one alkyl group and one hydrogen atom, and that alkyl group is an ethyl group. So over here is CH2 and CH3 will be bonded. And one hydrogen bonded to it. Alright. Z1 reacts with hot KMnO4, it forms only one product, which is ethanoic acid, which means that on both the ends of carbon-to-carbon double bond, it has one hydrogen and one alkyl group bond to it, and that alkyl group is methyl group over here. So C to C double bond. When only one kind of product is forming, the same kind of structure will be for each carbon atom. So, and it is forming only carboxylic acid, so one hydrogen over here, one hydrogen over here, and two alkyl groups, each on these two carbon atoms. So CH3 and over here to CH3. All right. Part 3, deduce the molecular formula of X, Y, and Z. They all have got 4 carbon atoms and 8 hydrogen atoms. Part B, the structures of V and W are shown. Part 1, name the class of compound that V and W each belong to. So V is a primary alcohol, while W is a tertiary alcohol. Part 2, V and W both react with sodium metal. Write an equation for the reaction of V with sodium metal. C4H9OH reacting with sodium. This gives us C4H9O and A plus H2. Now we need to balance this, so this will be half hydrogen. Part 3, name a reagent used to distinguish V from W. Describe any observation. So V was a primary alcohol and W was a tertiary alcohol. This is all part of theory. You need to learn all the reagents and their results with different substances. So reagent for alcohols, for differentiating between alcohols, is dilute H2SO4 with potassium dichromate 6 solution. Okay, observations. If I add this, okay, if I add this to a primary alcohol, my solution will turn from orange to green, while adding it to a tertiary alcohol would not make any change to the solution color. So solution remains orange. So we are done with this paper. Thank you for watching.